Welcome back, chemistry fans. Today, what we are going to do is our final homework dealing with this acids unit. It's something called the Henderson-Hasselbalch equation. So let's get into it. One more equation to simply be able to utilize. You only get to utilize this whenever we have a buffered solution, and it will always tell you that it is a buffered solution. So you will know. Now, in this equation, we are asked to solve for the pH. So pH is not just straightforward. Here is the amount of H's, because sometimes these H's are being consumed by the buffered solution. So we must take that into account. So the pH is equal to the pKa, which is weird. That's the negative log of the Ka value, plus the salt, which is the product divided by the reactants. Well, the products in this case, if we think about it, if we have some material that is giving off its H's, so I've got NH3Cl, it's going to give off H's and through H3, and it's also going to give one of its H, oh, sorry, this is NH4Cl. It's going to give away one of its H's. So the product is going to end up being this NH3 on top, what its concentration is, and the reactant is going to be the stuff on bottom, the NH4Cl, because we're looking for the material that has an extra H. That's the reactant side. The product side is going to be the side that would lose one of those H's. All right, so this ends up now just being a simple task of plugging in values. So negative log of that value, let's plug that in. Negative log of 5.5 to the negative 10 value, that gives us 9.26 plus, sorry, it's not just this. It's not just the ratio here. It is actually the log of that ratio. So I've got to put this in here as well. Sorry, let me erase this. Plus the log of that. So now I'm going to do the log of the NH3 is 0.75 and the NH4Cl is 1. So I've got to do the log of 0.75. And I end up with a negative 0.125. So 9.26 minus that 0.125 equals 9.38. So originally, whoops, no, that did not work. 9.26 minus 0.125. It goes down. And that's where it should be. Originally, we had this pKa, which is essentially how strong it is, how much of its acid is available. But then we have to subtract what is being eaten, available to be consumed by this buffered solution. So my answer comes out to be 9.14. Okay, so thank you very much for your time, and I will again work with you to try and get you prepared for the quiz coming up pretty soon. Thank you very much. Talk to you again soon. Bye.